This is section 9.2, extra example about American Idol. So what is the proportion we're talking about here? So on shows like American Idol, maybe this should be the voice now to be more current. We are wondering if there's an advantage. This is what we wonder: is there an advantage to going last? Because then the audience sees the last performer, and that's fresh in their mind, and so that they might vote for that person. So, is there an advantage? So, how do we figure out if there's an advantage? So, we take a random sample of 600 fans and show, in this case, the audition tapes of 12 performers. The 12 videos, the order are randomly determined. The order of the performance. So if the order doesn't matter, then 1/12 of the fans should vote for the last contestant. That would be the statement of no difference. If there's no difference at all, 1/12, that's our proportion. So what really happened? Did 1/12 vote for the last person? Actually, 59 over 600. So honestly, my first inclination is to put these both in decimal form and compare and see how far away from 1/12. Was it above? Was it below? But before we do that, we have to set up our null hypothesis. So, and you'll see. I do want to say that you'll see in the book and on AP tests, it's not going to tell you do a state plan, do conclude on the AP test. It's going to say, does this data provide convincing evidence of what blah blah blah. So, and that means that's a clue. That means do a state plan, do conclude. So, and then it'll just be blank. So the state is set up for you. We're going to use significance level 5%. Our null hypothesis is that should be 1/12 right there. P equals 0.083. So P equals 0.083, and our alternatives, since from context we're suspecting that perhaps more prefer the last performer, so we use greater than, and that makes it a one-sided test. So I just want to, so that you know the difference, I want to just say I want to write one-sided, that this is a one-sided test. Okay, so, and you have to say what P is. It's the true proportion of fans who prefer the last performer. You must define what P is. If you just write P equals, no one knows. Okay, so the state is done for you. The plan, we're going to just start talking about the plan rather than writing it out every time. So especially the random and independent conditions. So is the random condition met? Yes. Is the independent condition met? We're assuming there's at least 6,000 fans. And then the normal condition, I think we'll write that in our plan because some people are still missing that one. So what is the normal condition for proportions? What is it? NP and N1 minus P. Number of successes and failures has to be at least 10. So NP. So and which P do we use? The one defined in the null hypothesis, because that's what we're assuming to be true. So NP naught, if NP naught and N1 minus P naught both greater than equal to 10. And you can't just state that, you have to actually show the numbers. So it would be 600 times 1/12 is 50. So those are successes, and failures is 600 times 11/12, right? The complement is the other people. It's basically what's left over is 550. And so they're both greater than 10. So that's met, and we'll just talk about the random and independent without writing it because we've done it so many times. Okay, and now I do want to point out that the name of what we're doing is really important because we're gonna do other tests and intervals, and being able to identify the name. So this is called a one sample. Everything's been from one population, so it's called a one sample. Is it a Z test or a T test? Z test, because we're doing proportions. Proportions are always Z. with a normal distribution. So one sample t-test for, and are we doing proportions or means? Proportions, right? So for p. And I'm going to box that. That will be expected on the test that you can write the name of what we're doing. It's also going to help you find it on your calculator, to be honest. But you'll have to do multiple choice where you say what kind of test it is. Okay, so now we're going to do. So we're going to calculate what is, I'm curious anyway, like the first thing I want to know is what is p hat, because how far away is it from 0.083? And I can't tell that easily as a fraction. So the first thing I want to do is do 59 over 600 and see what I get. And so you get 0.098. So it does look like more fans prefer the last performer. However, is that difference statistically significant? So we have to take the difference of 0.098 and 0.083. So not even memorizing a formula, it should just make sense that you would take 0.098 and subtract 0.083. If you want to know how far away something is, you take the difference. But we need to know in terms of standard deviations. So we do square root of p naught, which is, again, we plug it in again, 0.083, and 1 minus p naught, the complement over the sample size of 600. And that's, okay, so you get, and you got to practice typing it in carefully too, but you get 1.33. Okay, that's, totally reasonable z-score. It's not, anything between -3 and +3. Okay, so that by itself doesn't tell us anything. Please don't forget to compute the p-value. There's another step. Okay, in confidence intervals, we were close to being done, but for this, we need to find the p-value. So the p-value is the probability that this test statistic, am I going to do greater than, less than? I want to know if it's further away, so greater than, because in the null hypothesis, in the alternative, you said p is greater than, it's going to be the same direction. Whatever you want to know how much greater, so you do greater than. It's either, what's the probability? It's 1.33 or more, and that's the same as normal CDF from 1.33 to a big number, infinity. What's the mean and standard deviation here? When I'm using z-scores, what's the default? 0 and 1 for the 0 for the mean, 1 for the standard deviation. So, and that gives us the p-value of 0.0918. Remember, we want a small p-value less than alpha so we can reject H naught. Do we get to reject H naught? We do not. Okay, so in other words, that difference could have happened by random chance. It's not so extreme that we have to worry, because there's a 9% chance that we could have gotten that result randomly. So it's not unusual, and that difference isn't big enough. We would need a higher z-score for the difference to be like, okay, yeah, there is a preference. So here's how you write your conclusion. So since the first part of the sentence can be out of context, since the p-value greater than alpha, we fail to reject. You either reject or fail to reject. Don't accept. Don't ever say accept. We fail to reject H naught. You can use symbols. Okay, so one sentence totally out of context. Don't even know what that means. So what it means in this context is basically what? What does it mean? Yeah.
We cannot prove from this that performance order matters.
Yeah, we can't prove that performance order matters. That's a good way of saying it in your own words. You'll often see it worded this way as well. There is not convincing evidence, but it's okay to say we can't prove. That's the same. There is not convincing there's not convincing evidence, there is an advantage to going last. Or however you want to say it, advantage to going last, but do say something that matters in context.